Good morning students. Today's topic is multiplexers. Okay. So first of all, multiplexer means many to one operation. So many to one operations means number of inputs are many and it gives a single output. So multiplexer block diagram can be explained like this. So we have to observe here, that is number of inputs. So number of inputs are represented by I0, I1, I2, I3 up to In. Okay. And one single output, that is Y. Okay. So to get different inputs as a single output, we are using selection lines also. So the selection lines are represented by S0, S1 up to Sn. So simple multiplexer block diagram represented by like this. Okay. So the multiplexer can be divided into different types of multiplexers, okay, based on the inputs. So the multiplexers are divided into like 8421 code. Okay. So 8421 code means we are observing that is 8421 code. The code can be extended up to 16, 32, 64, 128 like this. So each and every number doubled to the next number. Okay. So here we can explain 4 different types of multiplexers. So in this class I am explaining only 2 to 1 multiplexer, 4 to 1 multiplexer. So first of all 2 to 1 multiplexer. Here each and every number on the left side is the number of inputs and 1 represents the single output. Coming to first one, 2 to 1 multiplexer. So 2 to 1 multiplexer, inputs are 2, output is 1 and selection lines also 1, single selection line, because single selection, each and every selection line gives 2 possibilities, that is S0, S0 bar. So for 2 inputs we are using single selection line, that is S0. So the block diagram of 2 to 1 multiplexer, here 2 cross 1 or 2 into 1 or 2 to 1 also we have to represent. So 2 to 1 multiplexer means 2 inputs, that is I0, I1, one single selection line, that is S0 and output is Y. Okay. So before going to draw the logic circuit of multiplexer, we have to draw the truth table. Okay. So truth table means we have to represent selection lines and output only. So we already told in the starting, many inputs are converted into single output, means we can apply different types of inputs. From these inputs we can get single output at every time. Okay. So first selection line, we are using single selection line in 2 to 1 multiplexer, that is S0, S0 bar. So S0 is represented by S0 equals to 0 condition and S0 equals to 1 condition. So S0 equals to 0 condition can be written as S0 bar also. Okay. So S0 equals to 0 condition can be written as S0 bar also. So first condition. So in each and every condition we get only single output from the number of inputs. So S0 equals to 0 condition we can get single output, that is I0. S0 equals to 1 condition we can get single output, that is I1. So coming to the logic circuit, in this logic circuit we are using S0 direct line and S0 bar. To construct S0 bar we can connect one NOT gate or complement to the main S0. Okay. So this NOT gate represents the S0 bar. So single selection line, 2 possibilities. One possibility is S0, another possibility is S0 bar. Okay. So first condition, if S0 equals to 0, so S0 equals to 0, the output is I0. So first AND gate is represented by I0 one input and S0 bar is another input. So the AND gate output, so first AND gate, that is first AND gate output is I0 S0 bar. Okay. Next coming to next condition, that is the S0 equals to 1 condition. So S0 equals to 1 condition means we connect the AND gate by using 2 different inputs, that is I1 and S0. So output is I0 S1. So according to the according to the definition of multiplexer, it gives only one output. So here we observe two outputs. Now these two outputs are combined to OR gate. Finally we get single output, that is Y. So final output Y equals to I naught S naught bar plus I1 S naught. Okay. So now we have to prove this logic circuit can works as a multiplexer. For that we are using different cases. First case, S naught equals to 0 condition. So S naught equals to 0 condition means now the S naught value is substituted into the output Y. So S naught equals to 0 condition means this total term will be 0. Okay, this total term will be 0. So S naught equals to 0. In this situation, S naught 0 means S naught bar is 1. So this term is 0, but this term is as it is we can get as an output, that is I naught. So first condition S naught equals to 0, we can get output I naught. So first condition is satisfied. Coming to the second condition, if S naught equals to 1, so the same value is substituted in the output equation. I naught S naught bar plus I1 S naught. Okay, so S naught 1, so this term is 1. So 1 into I1. So S naught equals to 1 means S naught bar is 0. So this term is 0. So each and every condition we can get only single output. So this is the 2 to 1 multiplexer. The same operation can be applied to 4 to 1 multiplexer. So 4 to 1 multiplexer means number of inputs are 4. The 4 inputs are represented by I0, I1, I2, I3. So to represent 4 inputs or to design 4 possibilities, we can use 2 variables. Okay. So here variables means selection lines. So to represent 4 different inputs, we are using 2 selection lines. Okay. So 2 selection lines are S0 to S1. Okay, single output, that is Y. So coming to the truth table, 2 selection lines S0, S1. So 4 possibilities are 0, 0, 0, 1, 1, 0, 1, 1. Okay. So first possibility gives output I0. Second possibility gives output I1. Third possibility gives output I2. Fourth possibility gives output I3. So now we have to prove the truth table by using the logic circuit. So now we have to construct the logic diagram by using the selection lines and inputs. So we have 2 selection lines, that is S0 and S1. To using these 2 selection lines, we can differentiate into 4 combinations. So we can get S0 bar by connecting NOT gate to S0. By connecting NOT gate to S1, we can get S1 bar. Okay. So first possibility, that is 0, 0 possibility. So 0 can be represented by S0 bar and S1 bar. So here first and second and third and fourth and. So first AND gate inputs are I0, S0 bar and S1 bar according to the truth table left side. Okay. Coming to second AND gate, input I1, second possibility 0 means S0 bar, 1 means S1. Third AND gate, input is I2, third possibility 1 means S0, 0 means S1 bar. Next fourth AND gate, input is I3, last condition 1, 1 condition means S0, S1. Now these 4 AND gates are connected to inputs of OR gate. So finally we can get output combination, means addition of these 4 individual terms, like Y equals to I0 S0 bar S1 bar plus I1 S0 bar S1 plus I2 S0 S1 bar plus I3 S0 S1. Okay. So from this equation we can check the 4 conditions. First condition is 0, 0, 0, 1, 1, 0, 1, 1. So first condition 0, 0. So 0, 0 means only this term is 1 because S0 is 0 means S0 bar 1. S1 is 0 means S0 bar 1. So in this first condition, y equals to I naught, remaining 3 terms will be 0. So each and every condition, only one term converted into output, remaining 3 terms are 0. So first 0 0 condition, output is I naught, and second condition, output is I1, third condition, output is I2, and fourth condition, output is I3. Means every time we can apply 4 different inputs, but by using this equation or logic diagram, we can get only one output from 4 different inputs. Okay, this is for 4 to 1 multiplexer. The same operation also applied to 8 to 1 multiplexer and 16 to 1 multiplexer. So in examination, most probably 4 to 1 multiplexer and 8 to 1 multiplexer will be asked. So 16 to 1 multiplexer is easy to construct, but time taking process. Okay, so you are trying to 8 to 1 multiplexer and 16 to 1 multiplexer. Okay, thank you.